Okay, we get to sketch its graph given all this information. And your function might not look exactly the same as mine, but it should have the same kind of properties. Okay, so f of x, so let's draw this here. Let's do it again. F of x is 0 at x equals negative 5. So at negative 5, f of x is 0. F of x is 0 at 0. And f of 5 is 0. So I know it goes through those points. The limit as x goes to negative infinity. So if I get further and further out this way, the limit's infinity, right? So that means it's got to get bigger and bigger as I go out that way. The limit as x approaches infinity of f of x, these are my y values, is negative 3. Well, down here is negative 3. I'm going to go ahead and mark this like this so that we can see where it is. So as I get, oops, see if I can make this smaller here. As I go to, as x gets bigger and bigger this way, the y values are getting closer to negative 3, so it's actually coming down like this. That's what we call a horizontal asymptote. And I know that f prime of x is equal to 0 at negative 3. So what does this mean? This means it's got a horizontal tangent. That means the slope is 0, which means it's going to look like that. Or like that, right? So at negative 3, it's got a horizontal tangent somewhere. At 2.5, it's got a horizontal tangent somewhere. And at 7, it's got a horizontal tangent. Okay. So we got to figure out how do we put all this together. And there's lots of ways to do this. So I know one possible way would be, now it doesn't mean there can't be more horizontal tangents. So let's look at it like this. What if it came down here, hit that, and came up? That takes care of, I'm going to erase these. That takes care of that guy, right? Oops. At 2.5, there's a horizontal tangent, so it's going to come up and hit a flat spot there. And then somehow it's got to get back to the 0 at 5. So it's going to come down here. And there's a horizontal tangent at 7, right? So it's going to come up here like that. Now, how do I remedy this right here? Well, it says as x goes to infinity, the limit's negative 3. Can it do this? Is this okay? Come back down? Sure. Because it met all the requirements here. Could there be other places where there's a horizontal tangent? And the answer is yeah, there has to be one right here, right? Okay. Or it could just do something like this. How about this? What if here's 7 and it comes down here right like that and then just curves and goes down? So at that one spot, it's flat, but nowhere else. Okay, so that would work too. All right, let's take a look at 53. Suppose the weight W is the weight of a stack of papers in an open container. T is the time a lighted match is thrown into the stack. What is dW dt? Well, in words, that's the rate of change of the weight of the stack of papers, right? And let's look at it that in units. Units is always a good thing to consider to make sure we're good on this. W is pound, we'll say pounds. Per time is, it doesn't say time either, right? Minute. Okay, so that makes sense. The rate of change of the weight is pounds per minute. Now, if you're burning it, what's happening? It's getting smaller, so the sign of this would be negative. So A. So negative pounds per minute, so it's going down. B. What behavior of dW dt indicates the fire is no longer burning? Well, the fire is no longer burning, the weight is not changing, so the rate of change would be 0, means no change. And that's what no fire means. No change in weight. Okay. C. If the fire starts small but increases in vigor over a certain time interval, what does dW? Does dW dt increase or decrease? dW dt. So if it starts off small, so that it's changing, so it's a small negative number, say negative 1/2 pound per minute. Then a little bit later, the fire is increasing, so then later dW dt might be 2 pounds per minute, or negative since it's going down. Okay, so what does dW dt increase or decrease? Well, from negative 1/2 to negative 2 to negative 3 or 4 or whatever, that's actually decreasing because it's becoming more negative, right? Now look at the other part. Says, what about this? The absolute value. This is more like what we talk about, the magnitude. Okay, well that is getting, so 1/2 to it's getting larger. So that tells us the fire is getting larger. I should say this is getting larger, or they want to know what is the sign of that, or they just want to know if it's increasing or decreasing. So it's increasing. Okay, does that make sense? All right, shoot me an email if you got any issues. I'll be in my office Monday from, actually I'll be there early in the morning from like 7:30 to 9:30, and then I'll be there from 12:30 to 9:30, and then from 12 o'clock to 3 o'clock. So come in if you got any questions then. Thanks. See you.